gx, nothing else, and solve the equation. Correct?
So can you
Just
please?
put fx equal to gx. That will basically, so where it will intersect when these two curves meet, right? That means it is fx equal to gx. At those points the curves will meet. So you will get an equation with respect to x. Correct? Then solve the equation. That is basically what we have asked, nothing else. Okay?
Sir, I had 9 and 7 in this, so I got 6.
Yeah, fine. Fine. That is fine. So that is basically different numbers are coming here. That's why different equations you are getting. Okay? Okay?
Hello.
Uh, yeah.
So question number 1 also.
I will not solve the graded assignment for week 4 because the solution anyway will be provided, no? So is question number 8 clear to everyone? I mean, it was not very difficult question. Let me write it if you want. So, so what we are getting, I have two equations like this. Fx is basically x minus 19 and x minus 17 whole square, right? This is what we are getting. Yeah, this is what it is given. And gx is minus x minus 19 and x minus 17, correct? So if I give fx equal to gx, that is basically will give us all point of intersection, correct? So what I am getting? I am getting this. Okay. So if I take all these terms in one side, I will get this. And eventually what I can do, I can take x minus 19 and x minus 17 as a common factors. So I am left with this, correct? This is what I get. Now x minus 19, x minus 17 and x minus 16. This is what we are getting, correct? Now the first two are basically your when fx equal to 0, that is what it is, right? Y-intercept. So the rest term is x minus 16 equal to 0. And this is what is the x coordinate of the third district. That is what we asked. Is it clear?
Yes, sir. Clear.
Yeah, great. Okay, fine. What was question one? Someone was asking. No?
Yes, sir.
Yeah. So R to R, this function is given, gx is minus 2. So you just find out what gx is. Minus 2x cube minus 16x square plus 14, right? Then you have to answer these questions. I mean, you have to find the graph of this function.
So one doubt in this question is,
Hmm.
nine was one of the x-intercept of the equation. Okay, so the curve was passing through 9. So in this question, the number is different. So let's say the point is passing through 10. Okay, so
So
if the
here it will
question
pass through 10.
asks,
Yeah.
yeah, so if the question asks that from point 9 to infinity, the graph
Uh,
is the curve is increasing infinitely. So
uh.
that is why is that wrong?
No,
Like
it is
the
not
point
wrong.
10 will
It is
uh,
asking about point F, right? And F is strictly increasing in the interval.
yeah, so what if the 9 was not sorry, 10 was not included in the interval?
What if 10 is not included? Then also it will be strictly increasing.
Okay.
I mean,
If
that
the
does not
bracket
change
is
it.
not included, that doesn't change it, right?
No, in this case, it does not change it because from
Okay.
10 and onwards, it will be increasing function. And 10 is acting like a boundary of that increasing interval. That's it,
Sure,
nothing,
sir.
nothing else. If someone give it as 11, then also it is fine. The graph is increasing.
Okay, sir.
Okay. Yeah. Okay. So fine. Let's move to week 5, I think. Again, we will select some questions. And have you seen week 5 yet? Because I think quiz is on next week. So have you got the time to see the content of week 5?
Yes, sir.
Yes, sir.
Okay. So it start with basically one-to-one function, right? And then we'll move to exponential function, and then there is something called composition of function. And one-to-one function we have seen in week 1, right? Can someone just recall what one-to-one function was? Anyone?
So can I?
Yeah, go ahead.
For every x1 and x2 belonging to the domain in A, for instance, then
Mhm.
fx1 also equals to fx2.
That is always true for a function, right?
Oh, sorry. Rather, we have to say like if
Opposite.
fx1 equals to fx2, then
Exactly.
it has to be x1 equals to x2.
Exactly. Correct. So,
Otherwise we can say like x1 not equals to x2, then fx1 not equals to fx2.
right. So just I think all of you are remembering this because this is in week 1 chapter, week 1 syllabus. So you remember what something is domain of a function and something is codomain of a function, right? Domain is from where we are taking inputs, codomain where we are expecting the output. Now, if for two defined input, I am getting a same output. If this is happening for two different input, two different x1 and x2, I am getting same output. Then this function is not one to one.
Many ones.
Huh?
It is many one.
We don't really call it many one. So now not one to one is enough. Okay. Many to one is not a good terminology for math. That I will say. Okay. So this is what not one to one function is. Right. If this does not happen, then we call the function as one to one function. Okay. So suppose I am giving you an example. So the usual example which I start with x square plus 9 maybe. Is this function one to one? Is this function one to one?
No,
No,
sir.
sir.
Why?
For the value x is equals to 1 and minus 1, both will have the same answer.
Exactly. So basically the square, this parabolic function, this type of function you have seen. So for plus and minus, we are getting the same square. So for 1 and minus 1, both of them, the value will be same. So it is not one to one function. Okay. What about fx equal to mod x? This is also clear, right? Is
Even
this
this is
function one?
not.
Not.
This is not. Correct. The answer is again no. Because for again negative and positive, they will give the same value, right? So this both of them are basically one. Okay,
Like,
so
sir,
can
x square equal to 9 means minus 3 also will come 9. 3
x square
also
equal
will
to
come
x
9.
square plus 9 I have written. This is a function I am writing, not an equation.
Okay.
Okay.
Okay, sir.
Yeah, whatever positive and negative value you choose, plus 2,
Yes.
minus 2, whatever, so
Mm.
it will
So it
always
is
give the
not
same.
1 to 1. Yes.
Yeah, it is not one to one. Yeah.
When will the assignment graded solution will be uploaded?
When was the deadline? Yesterday, is it?
The day
Yes, sir.
before.
Okay,
Yes.
then it should be uploaded till now. I will ask the
It was
team to upload
uploaded.
it.
I checked that.
Oh, it was uploaded. Oh, see, it is already uploaded. Yeah. Okay. There was
When
one
it is,
type of question. Huh?
I have checked o'clock. It was not uploaded, sir. Today, I have checked.
No.
Say supplementary content.
Supplementary content, under supplementary content you go, I think it is uploaded. Graded
Can we
assignment
check the one?
solution. Yeah, here it will be uploaded. I mean, it is opening very slow. But in supplementary, yeah, if you go to download now, then I think there are Week 3. Okay, I am not seeing it. So I will ask the team to upload week 4. I am not seeing week 4 is uploaded here. Okay, I will upload it by tonight. Okay. Anyway, so if I ask you this question, x plus 9, okay, can you tell me what is the minimum value of the function?
9.
Is it?
No, sir.
Okay, one of you are saying it is 9. What about others? What is the minimum value of this
0.
function?
0
Zero.
at -9.
0.
Exactly. So it's whatever is inside mod, it will always, the minimum value will always be 0, because there is some x for which it will give 0, and that will give the minimum value, right? It can never go to negative, so minimum value is always 0 for this function. Okay. So I think this type of question was in week 1, and this is really important. So as the quiz is nearby, so I am just recalling this. And what if I write this function? Now what is the
Sir,
minimum value?
sir, x plus 9, can you explain one more?
The 9
The 9.
Now it's
For this
9.
it is
at
9.
x equals 0.
So for x plus
Ah,
9,
absolute
whatever.
value. Okay, yes. I forgot. Yes.
Yeah.
Just to 9. Absolute
Yeah.
value, no? I
Correct.
forgot. Yes.
Yeah. So this is for this. This is 9, because for mod x the minimum value is 0, and so if I add 9, then it will start from 9. So can someone tell me how the graph of this function look like?
Yes.
Suppose it is 5 here, somewhere it is 9.
That
Okay,
is
so
a
this is the
V
Yes,
minimum
sir.
value.
V type of graph
Sir,
above 9.
Exactly. This is how it look like. Correct?
oh,
Yes, sir.
Okay. So the minimum value will be at x, this 9 at y-axis. So this is the minimum value, and at x equals 0, that value is added. And then from the positive side, it is basically x plus 9, and from negative side, it is minus x plus 9. So this is how the graph will look like. Is this function one to one?
No, sir.
No, sir.
No, sir.
No.
Is not, right? So one thing which came in week 5, that is horizontal line test, right? If you just draw a line horizontally parallel to x-axis, which can't intersect the graph, and if it intersects more than one point, as you can see, then we call this is not one to one. And what is the reason? Because what does horizontal line represent? That is the functional value for the function, right? For some x. So for two different x, this one and this one, the functional value will be the same, right? For two different input. And when that thing happens, then it is not one to one. Is it clear? Is it clear to everyone?
yes,
Yeah.
Yes, sir.
Okay.
yes,
Okay,
sir.
great.
Minus value also will come. Positive
Ah,
value, negative value also will come the
yeah.
answer. So it is not 1 to 1.
Correct. Yeah. So this type of question, even this type of question may come in quiz also, right? This quiz one. Although this one to one horizontal test came in week 5, but this all the concepts were there in week 1. Okay. So this type of question may come. And just one last question for this. Suppose I am asking you this 9 minus mod x. Now, can you tell me what is the maximum value of fx and how the graph will look like?
9.
Maximum should be
9.
9.
9.
Maximum value
Minus
9.
9 below arrow will come below, I think.
Inverted
No.
V. Inverted V, sir.
Minus
Yeah,
infinity.
inverted V. It will look like this. Right? And the maximum value is attained at 9. So basically, it will be the negative of the earlier one which I have done, that is x minus 9. Right? I am just taking negative of that, a reflection of that. Earlier, it was like this. Now I am taking a reflection with
Thank you
respect
so
to
much,
this.
sir. It was wonderful.
Yeah.
Thank you once again.
So this is about this mirror. I am basically taking the reflection. Okay, is it clear? So if someone asks what is the reflection of gx with respect to y equal to 9, that is basically this function. Yeah. Has anyone has any doubt in this? Okay. So I think one-to-one function is more or less clear. If anyone has any doubt till this point, you can ask. Otherwise, I will move to
No, sir.
exponent.
We can
Sir,
move
will
ahead.
you revise the week 1, week 2, week 3 anytime in this week?
No, that is there is a revision session for that, right? In next week.
We don't see anything for max in the revision session.
No,
Will be
there
there,
is
but not
revision
now,
session.
maybe.
Okay, there is revision session. It will be there. Okay. So I just revised this portion because this is common intersection of week 1 and week 5. That's why. Okay, fine. Let's move to next portion of week 5.
Sir, we have to join in PD.
No, you don't have to join here. I am just using the slide to solve the problems.
Okay.
So suppose I take this problem, right? 2p equal to q, where p and q are any real number, and I give you to find this value. Can we solve it? I hope everybody has pen and paper with you. Can you just try to solve this? Then we'll see.
Sir, 2.
Okay, you are saying 2. Okay. What about others? Let others solve for it.
Yes, sir, 2.
Okay. So I am waiting for one
Yes,
more
sir, 2.
so that other can solve. Okay, so I think this is quite easy, right? 4 power p by 2 power q. So if I write it, 4 power p by 2 power q plus 25 power q 625 power p. 25 power q 625 power p. And one condition given is 2p equal to q. This is the condition. So what we generally do, so you can see that this 2, you can write is 2 power 2p. This. And here also I can write 25 power q, and this is 25 square. So 2p. So what I get? 2 power 2p minus q, because this is division. So indices will be subtracted. And this is 25 q minus 2p. As 2p equal to q, then both of these indices are 0. And something power 0 is 1. If that is non-zero, a power 0 is 1 whenever a is non-zero. So what I get? 1 plus 1. That is 2. Is it clear? So this was, I think, easy problem. Anyone has any doubt in this?
Clear.
No, sir.
Okay, great.
No, sir.
Great. So let's move to the next question. So half-life of an element. So I think this type of thing you have seen in class 11, 12. So half-life of an element is the time required for a half of the given sample radioactive element to change to other element. So the rate of change is given by this. At t time, if it is a function of time alone, then a naught into 1 by 2 power t by gamma, where gamma represents the half-life of the material. We have defined what half-life is. A naught is the initial concentration. At the beginning, we start with some concentration. Suppose material. So suppose we have some 5 ppm of concentration of the radioactive element. Then this is the equation we are getting, and it is the concentration of the radioactive element after of the sample after time t. So we are seeing that AT is basically a function of t. That is what is more important. Where A naught and gamma are some constant. They are fixed, right? The initial amount will be fixed, and gamma is the half-life of the sample we are dealing with. Right? So these two are constant term. So it is only depending on the term t, right? And that is coming at the exponent of 1 by 2, right? So this is what the function is. Now we have started with radium. So half-life of radium is given by 1600 years. And the initial concentration we have started with 100%. Then calculate the percentage of radium in the sample after 2000 years. So we have started with radium with some concentration, total radium. So A naught is basically 100% of that. And we have to find after 2000 years what will be the concentration. Is the question clear to everyone?
Yes, sir.
Yes, sir.
Okay. Okay, so I will give you 2 minutes to solve it. It will be, I think, easy to solve. So take 2 minutes and give the answer in the chat. Okay, not verbal. Okay, let me see if some of you have given answers here. 42%. Okay, fine. So what we actually are getting. So if I write down the equation, AT, if I write down the equation, this is A naught 1 by 2 T by 1600. Right? This is what the equation is. And this is at, so after 2000, that is what we have to calculate, right? After 2000 years, what is the amount? So this is nothing but this is what we have to calculate, correct? Is it clear to everyone? This is what the equation is, right? So initially it was A naught, and after 2000 years it was like this. So if I find out the ratio, so this is 20 by 16, that is 5 by 4, A naught into 100. This is the percentage after 2000. Correct? And we have to solve this. A naught will cancel out. Now we have to calculate this value. Okay, it will come nearly 42%. Okay, is it clear? I think most of you have done this. Anyone has any doubt in this?
It's clear.
It's clear. Okay, great. So
Sir,
yeah, this
can we
is
take
what.
a not as 100?
Yeah, then also we will get the same thing. No?
Okay.
So A naught is basically the initial concentration. So it is, so 100% area means there is no other impurity. That is what it is. So this is the approximate percentage 42, which we will get. Okay. Now there is something in this section. There is something called composition of two functions. Have anyone of you see composition function earlier? So what it does basically, so suppose I have a function like this, f. So this is the domain of this f. This is the codomain of f. Okay. Now we are applying another function on this. So this is the domain of f. What is this portion called?
This is range.
Range of f. Correct. This is range of f. Now, if we apply another function from here on the range of f, okay, then we get something here. So maybe domain of G is something bigger than that. But we are applying only on the range. If the range is inside the domain, then only we can apply G. Otherwise, we cannot. Okay, because you know this portion should be inside the domain. This can be taken as an input of G. Then only we can apply G. Okay, and this is the codomain of G. We can apply something, and whatever we get here after applying G, this total thing is called G composite. First we are applying F, then we are applying G. So what we are doing basically is, what is G composite of X? This is G of f of x. First we are applying f to some input, then whatever the output we are getting, I am applying G to that. Okay, this is called composition of two functions. Okay, so is the diagram clear? Whatever we have drawn, because this diagram will play a very important role in finding the domain of this one.
Yes, sir. Very clear.
Sir,
Yes.
small doubt.
Yeah.
Small doubt.
Yeah.
Regarding, sir, the domain of G
Huh.
should be the range of F, no?
I mean,
Or
it should be a subset of that, not necessarily equal. Okay. Then
my
only
doubt
we can
is,
apply, no?
the domain the domain of G should be the range of F or the codomain of F.
No, the domain of G should be a superset of range of F. That is only needed. So we need range of F to be inside domain of G. That is what only we need, nothing else.
Okay.
Okay. Yeah.
Okay, sir. Thank you, sir.
Otherwise, if some portion of range is outside the domain of G, then on that portion we cannot apply G. That is what it is. Okay.
Okay.
So yeah.
So we can extend this infinitely now, right? They're like h of g of f and so on.
Right. And this can go on. Yeah, correct. So suppose we start with this an example. Let's take an example that will be clear. R to R. Okay. F of x is x square. G R to R. G of x is root x. So first of all, it should not be R, right? It should be R plus. Domain should be R plus of G. Correct? Is it clear? Because negative number cannot be under root.
Root, yes. Yes, sir.
So domain of this G function should be R plus. So this is two things. Right? Here domain is R. And yeah. So now if I apply F first, then G. So I want to find what is G composite. Okay. This function I want to find. So first I am applying F. So domain is R. What is range of F? So codomain is R given, codomain of F. But what is range? Can someone tell me what is range of this function? First one. What is range of this function?
X square.
Positive number or
Positive real numbers.
Only positive real number, right? No
Positive.
negative number can come, including 0. Correct? So this is basically R plus. This is the range. Clear? This is F. So now on this, now see, this is actually the domain of G. So I can apply to every element of this, I can apply G. So this is where I can apply G. Correct? So this function is defined. And what is this function? G compose f of x, G of f of x, and f of x is basically x square. So G of x square. Now what is f of x square? Sorry, G of x square. What is that? What is this function?
X. X, sir.
It is basically this, right?
Yes,
This
sir.
function.
Yeah.
Can be plus or minus x.
So now there is a question. So suppose I am writing G compose f of say 2. G of fx, G of f of 2. What is f of 2? What is f of 2?
4.
Now I am writing G of 4. What is G of 4?
2.
Right? It is
Plus
just
minus.
not plus minus 2. Not plus minus 2. Because this is under root. This is always positive. So if I see what is the range of this, this is also R plus. Because when I am writing root 2, what I am defining? This is positive root 2, right? Because there is some notation called minus root 2. This is the negative part. Correct? So if some number is under square root and there is no sign before that, so that means this is positive number. Okay? So whatever I am getting here is basically x. Right? And so that depends. So for 4 it is clear, right? It is 2. Now what happens if we take this minus 2? What is f of minus 2?
4, sir.
So this is again 4, right? And what is this one? So root 4. This is also 2, right? So for plus 2, we are getting 2. So this portion is always positive. But for negative numbers also, this is turning them into positive after this composition. So what this function actually is, this composition function, this is nothing but mod of x. Is it clear?
Sir,
Because
why you are not taking negative root?
negative value.
First. No, when I am writing something, is this positive or negative?
It can be both, right?
No, it is positive. Because for negative root 2, there is a notation like this. This is the negative root 2. What you are saying, this is what you are saying, 4 power 1 by 2. Right? For this, I can have two values, plus 2 or minus 2. But this is a function, right? So I should have only one value for this. I cannot have two values. Otherwise, it will not be a function.
Yeah, I got it, sir. Thank you.
Yeah. Yeah, this is very important point. I mean, many of the students are doing this mistake. So whenever I am talking about square root of x, then this is the positive square root I am talking about. Okay. If I give you negative here, then this is the negative square root. Otherwise, it will not be a function. Okay. But the point here is different. Point here is, if I take 2, g compose f of 2, I can see the value is coming as 2. But if g compose f of some negative number, say minus 2, I am taking, then also after doing this composition, I am getting 2. So if I take negative number or positive number, eventually I am ending up with a positive number because g of x is basically root of x, which is positive number. So root of x square is what? Is basically mod of x. Is this clear? So this is not x, this is mod of x. Clear? Anyone has any doubt? Or should I explain it once more? Or is it
Sir, please
clear?
explain once more. Sir,
Okay.
please explain once more.
Okay, fine. Okay, so again, observe this. I am writing. So G compose f of 1 or 3. Let's say 3. So what is G of f of 3? That is what we are finding. So what is f of 3? It means 3 square, right? That is 9. So G of 9. Okay. And what is G of 9? It is root 9. Now what is root 9? It is 3. Correct? Because I have already said that root x is positive, always positive thing I am talking about. Okay. Now, what is G compose f of minus 3? This is G of f of minus 3. So this is G of minus 3 square. That is again G of 9. Again it is root 9, again it is 3.
9
So
only,
G
sir.
of, no, root of 9, that is 3. So if I take G compose f of 3, I am getting 3. If I am taking G compose f of some minus, negative number, minus 3, I am again getting 3. So basically, for G of f of x, if x is positive or 0, then I am getting x. If x is negative, I mean x is less than 0, then I am getting minus of x.
Minus.
Correct? Because for minus 3, I am getting minus. That is 3. It will be alter the sign. Correct? And this is the function, basically, this is the mod function. Correct? So G compose f of x here for this case is nothing but mod of x. Is it clear? Basically,
Yes,
if I write you root of x square, this is nothing but mod x. This is the main sketch of the problem. Okay? Clear? Understood?
yes, sir. Yes, thank you.
For the same function, if I do f compose g, can you tell me what that is? Same function, r to r. So this is f of x is x square, g again r plus 2r, g of x is root x. Okay. Now I want f compose g. This is what I want to find. Okay. So from where we are starting? We are starting from r plus. Now this is not r, so we are starting r plus. From r plus we are starting. Okay, from r plus, and whatever thing I am getting here after applying g, this is also r plus. Correct? This is G. Now, see, F is defined on whole R. So domain of F is R. But here, I can only apply F on this R plus because I am doing composition. I can only apply on the range, right? That is what I was talking about when I have given the definition of F composite. F is applied on whole R. This is the total set R. But I can apply on R plus only because I have to apply it on the range of G. So range of G is R plus. So here I am applying F. Okay. And this is where I will end up with. It will be also R plus because only positive thing will come here. Okay. Now can you tell me what the function is? Is the diagram clear to everyone?
Yes, sir.
Okay. What is F compose G?
X.
Sir, X.
Right. So G of X is, so first we apply G of X. G of X is root X. I am applying on root X. So here only positive numbers are there. So F
To
of
the whole
X,
square.
X whole square. That is only X. Yeah. So for this function, F compose G, this is X. But G compose F, this is mod X. Clear? So they may not be equal always. Okay? And
Sir,
if I
they
ask
may
you
be
what,
equal.
they may be equal. They may be equal. There are some
Okay.
cases which we will see. They may be equal. And for before going to that portion, what is domain of F compose G in this case? And what is domain of G composite? So F compose G we have done right now. So domain means from the origin, from where we are taking the input. So we are taking the input from R plus only because G is defined on that. And once that is defined, then F is also defined. So I can apply F on that. So in that case, domain is R plus. So domain of F compose G is basically R plus. What is G compose F? If you see this is G compose F. So F is defined on R. From R I am taking input. And once that is defined, then Fx is defined and G is defined on Fx for all x because it is anyway positive. Correct? So eventually the domain of G compose F is R. So this is R. So domain also, domain of F compose G and G compose F also can be defined. Is it clear?
Yes, sir.
Yes, sir.
Yeah. So this is really important thing for composition of two
Sir,
functions.
in f of g,
Huh.
will it not be mod of x?
F of G, F compose G is X because it is root X whole square. That is just X, nothing. Because it is defined on R plus only, so it will always be positive. Okay. What is domain of F compose G? That is what we have written now. F compose G, domain of F compose G is R plus, this one. Because the input we are taking, that should be inside the domain of G first. So
Yes,
that
sir,
is,
that I understood.
and this is eventually root X squared, so it is X. Mod X makes sense when basically we have something from negative side also, but that is not happening. Only X is enough.
Okay, sir.
You can write it as mod X because this is only on R plus. So mod X and X is same thing on R plus,
Yes,
right?
sir, I got that.
Yeah. That is what the function is. So clear, this fourth thing is clear to everyone. Okay.
Yes, sir.
So let's take another problem and see what is happening. Yeah.
Sir,
Two
excuse me, sir.
functions. Yeah. Tell me.
Sir, I have a doubt in activity question 5.2. Can you take this?
I will come to activity question later. If all
Okay,
these things
okay,
are
sir.
done, then I will come.
So we have to find both.
No, I am giving you the question. So question is what is the domain of G composite? Okay. This is what the question is.
Sir, -1 infinity.
Yeah, is there any other option which is also correct? Have to check that also.
Second option.
Yeah, I will discuss. Let others solve also. I will wait for 1 minute and then I will solve this. Okay. Okay, so should we start discussing this? Or do you want few more minutes to try? Let's see how many of you have given. Only one answer I am seeing. What about others? Okay, so let us write the question, then we'll discuss. So if x is what? If x is x plus 1 power half. Basically square root of x plus 1. Because this is a function, so I cannot take 2. And gx is x square minus 1. Okay, so these were the function. Can you tell me what is domain of f?
-1 comma infinity.
Correct. Domain of f is, and should we include -1?
Yes.
Yeah, because for that is 0. So -1 to infinity. This is domain of f. And what is domain of g?
R.
R. Yeah. Everything, every real number will be taken as input. Okay, fine. And what is range of this? Range of it. What is
0
range
comma
of?
infinity.
So only positive, right? R plus 0 to infinity. Correct. Because this is only positive numbers. All the positive numbers will come. Okay. Okay, fine. So if I what I have to find, I have to find the domain of G compose F. So I have to apply F first. So I have to apply F first, and then I have to apply G. Correct. So from where I have to take the input first, I have to take the input first from this minus
-1
one
to
to infinity. Right. This set, suppose this is -1 to infinity. From this set, I have to take the input. Right. And whatever the input it will come, it will be inside R plus. Now G is defined on whole R, so it will obviously define on R plus, right? So G composition F is defined, and whatever we get eventually we will get it here in R something. So the domain of the function, the composition function, is basically domain of G compose F is basically -1 to infinity. Okay, is this clear to everyone? Is this question clear to everyone? Okay. Now, is there any other option which is correct? So if you see option, let us check what option 2 is, because first and fourth option is not correct, that is clear, right? But we have to check for option, this one, option 2, -3 to infinity, open bracket is there, then set -3 to 5, intersection -5 to -1, this. Okay, so if I draw the number line, bad number line. So if I draw a number line like this, here it is 0, somewhere it is -3. Okay, -3 to infinity is basically this part, right? Not including -3. Now -3 to 5. So here it is -3, here somewhere it is 5. So this portion. And intersecting -5 to -1. So somewhere here it is -5. -5 to -1. Here somewhere it is -1. This portion. So what is the intersection of these two?
-3 to -1.
-3 to -1. And it is open bracket, right? So this portion is basically, so if I draw this portion, this is nothing but -3 to -1, open bracket. So what we need, from -3 to infinity, -3 to -1. This is what we need. So from -3 to infinity, I have to eliminate this portion, open. So what I have left with, -1 to infinity, correct?
1 to infinity, -1 to infinity.
And one will be included, because
Yes,
here one was
-1 included. Outside, open.
Yeah, so this is what it is. So the second option is also denoting the same thing, -1 to infinity. So this is also, this option is also the domain of G compose. Is it clear?
Yes.
Okay, so now can you tell me what is actually G compose F? What is the function?
X.
So if I write G compose F, so G of F of X. Now F of X is √x plus 1. Now G of this is x square minus 1. So this square minus 1. So eventually it will come as x plus 1 minus 1. It is x. Is it clear?
Yes.
Okay. Now what is F compose G for the same function? Can we calculate it? F compose G. So remember F was √x plus 1. G was x square minus 1. What is F compose G? And we have to also find what is this function and what is domain of f composite.
The mod X.
Okay, so let's try to find it. Okay, what is what is the domain of G? First of all, domain of G is real number, all real number. But what is range of it?
Minus 1 comma infinity.
And is minus 1 included?
Yes.
Yes. So basically, x square has minimum value 0, right? What we are starting at the beginning. So this
Sir,
has
this
minimum
is from
value
which week, sir?
with 5.
Yes.
No, why are you asking now? Which week is it?
Sir, actually, I just joined, so I was having another college
Oh,
class.
okay, no issue. Okay, so x square has minimum value 0, right? So the minimum value of this function will be minus 1. From minus 1 to infinity, I will get anything. So this is the range. And you know what is the domain of f? Domain of f is also minus 1 to infinity. We have seen. So yeah, on the range of it, I can apply f. That is the idea. So G, I am taking everything from R. I am applying. I am getting something here. This is minus 1 to infinity. And on this, I can apply f because indeed it was actually the domain of f. So I can apply and I will get something here. Okay. So if compose G is well defined, and so what is the domain of if compose G? I can take any input from R, right? And I apply G, then I can apply F. It is well defined. So this is R. Clear? Is it clear? So earlier for G compose F, the domain was minus 1 to infinity. But in this case, domain is R, the set R, all real numbers. Okay.
So,
Now
sir,
what is
one could say that the domain of the function, composite function, is the value function and which is on X, which
what?
replaces X.
No, I mean, it may not be always the domain of this function. It may not be always like that because eventually the range of that function should be inside the domain of the next one. Otherwise, we cannot take those elements. We have to eliminate. I will give you an example for like that also. Okay. Every
Yes.
time you have to see what is range and domain of this first function, then you can say that. Okay. For this function, it is R. Is it clear? This one?
Yes.
Okay. Now, what is f compose G if I ask? So f of this was what? Gx was x square minus 1. X square minus 1. And then I am applying f to that. Right? And f was root over x plus 1. So here x square minus 1 plus 1. So root over x square. And this is what we have seen earlier. This is mod x. Correct? Because why mod x is coming here? Because I am starting from R. Anything from R. Okay? So negative numbers are also there. So mod x is important here. This is not only x. So f compose J is mod x here, but G compose x was x. Clear? Is it clear to everyone?
Yes, sir.
Yes.
Yes.
Okay, great. So let's move on to the next one. So I don't want to
Sir,
spend time on
previous one
this.
was not clear to me, sir.
Which one? Which one?
Sir, G of F, the domain,
This one?
yes, sir, it's G of F.
G of F domain, right?
Sir,
This
how
one.
it, how it will be minus 1 to infinity?
What is domain of F? Can you
Sir,
tell me
minus
what
1
is
to
domain of
minus 1
minus
to
1 to
infinity.
infinity, right?
Yeah.
So first we have to, for G compose F, first we have to apply F, right? So from
Yeah.
where I can take the element? From -1 to infinity, right? Other than that, I cannot take any element, right? Except
No,
-1 to
sir.
infinity.
Yeah.
Right. Then I am applying f, and in what is the range of f? This is r plus, right? All positive number will come. So, and domain of G is whole R. So eventually G can be applied on the range of f. So whatever values inputs are coming from -1 to infinity, after applying f, whatever the value is coming, I can apply G onto that. So domain of G compose f is nothing but domain of f in this case, which is -1 to infinity. Is it clear? Is it clear, or you have some
Sir,
doubts?
clear, sir. Clear, sir.
Okay, great. Great. And remember this diagram, this will clarify many things. Okay, fine. Yeah, so before going further, there is another this exponent problem. Let's solve it and then we'll go. So in your survey population, again in terms of alpha, this equation is given. So alpha is the function in terms of t. T is the times in the initial population count. And initial population count is alpha naught. And D is the percentage of growth. Right? So if in 2015 the population of Adyar is 30,000 and the population growth is 4% per year, then what will be the approximate population at 2020? So T0 basically 2015 and T1 is 2016 and so on. Okay. So can you just calculate this problem and then we can check.
Give me some time, please.
Yeah, yeah. So take 2 minutes and then. Should we start discussing this? Okay, so this is the equation which we have to deal with. And alpha naught is given as 30,000, D is 4%, T is 5. Right? This is what all the parameters are which are given. So if I write this, so approximate population at 2020 will be alpha of 5. So I just put this value, all the values here. And eventually, if we calculate it, this will be 36,500, something like that. Okay? Is it clear to everyone? I mean, this is just putting all the value and calculating, nothing else. Okay? Anyone has any doubt in this? No? Okay. So I'm moving forward, okay? Yeah. Okay, so this is the question which now I am interested in. So fx is x square on the restricted domain. So I am taking the domain only to r plus 0 to infinity. And why is that? There is a reason. Then choose the points where the graphs of the function fx and f inverse x intersect each other. Now, what is f inverse x? So, before going to
Under
solve
root
that
x.
problem, so before going to solve that problem, what is f inverse x? So, if there is some function g for which this and these are same, and both of them are equal to x, that is identity function on x. If this is happening, then we call in that domain, in a particular domain, if this is happening, then we call G is F inverse. So we call G as inverse of S. Okay, inverse function of X. Because we are applying it to get the identity function, right? That is why it is called inverse function. Okay, so here what is given? Fx is x square, right? And so we have seen earlier if it is from R to R, right? And G R to R, not R to R, R plus Gx is root x. And when we are applying, so what was G compose F we have calculated, if you remember this example. Yeah, this example. Okay, F compose G was x, but G compose F is mod x. Now, why this second part is also x in this particular case? Because we are restricting our domain of 0 to infinity. So we are only dealing with the positive real numbers, r plus. So mod x and x is same in this case, correct? So if we are restricting the domain 0 to infinity for both the functions, right? Then what we will get? Then both of this function is basically x, identity function, and they are equal. Correct? If we are restricting both of them as r plus, these are also plus, this is also r plus. Both of them are restricting on that. Then only these two functions will be equal. Correct? So in that case, root x will be the inverse of x square. Right? If both of them are on r plus. Then g compose f and f compose g, both are equal to identity function. Yeah. So f inverse in that case is root x. Is it clear what inverse function is?
Yes, sir.
Okay.
Yes, sir.
So now the question, what was the question? Question was choose the point on where the graphs of these two functions intersect each other. Right? So where fx and f inverse x are equal. That is what we are asking. So what were those points? So x square should be root x. That is the equation I am getting. So x power 4 is x. if I take both on one side, this is the equation, and which is giving us this. Correct? So I can break it further. This is what I can do. Correct? Now this portion does not have any real root. How we can confirm that?
Imaginary roots.
Huh?
If roots are imaginary.
No. How we can confirm that? How we can check that?
If D is imaginary.
B.
D, sir. Discriminates.
Discriminant, right? That is b square minus 4ac, right?
Yes.
So b square minus 4ac, this part. So here b is 1, 1 into 1. So 1 minus 3, this is negative. So if discriminant is negative, then these roots are not real. This equation does not have any real root. So what are the only real roots here? 0 and 1.
0 and 1.
0, 1.
Yes, at these 2 points, at x equal to 0 and x equal to 1, they will intersect each other. Clear? So if we see the graph of this function, so this is all. These two are the fx equal to x square, and this is root x. If you see, they will intersect only at 0, 0 and 1, 1. Yeah. So this is what we need. Okay. So whatever we have discussed till now, is it clear to everyone?
Yes.
Okay. Fine. So this is basically more or less what all the concept of week 5 is, right? Week 5 does not have many difficult concepts. So the main thing is there, which is composition function and inverse of a function that we have dealt with. Then at the beginning we have one-to-one function and horizontal line test, and in the middle portion we have exponent function. So these three are the main concept of week 5. Okay. Anyone has any doubt in week 5 till now? You can ask me. I have no more problem to do. If you have any questions, someone was asking some activity question from week 5. Can you tell me which one?
Yes, sir. I have a question regarding activity question.
Huh.
5.2 question number 3.
Okay. Let me see what question is that. Increasing and decreasing function, right?
Yeah, yeah, sir.
Yeah. So which one are you talking
Question number
about?
3, sir.
I mean all the options. Do you need help with?
No, sir. Actually, I have a doubt that since this is decreasing function, so we are taking only the positive real numbers or entire real numbers?
No. Entire real number set in its
So,
domain. So here it is written no, for all x. These are all written.
yeah. So,
Yeah.
sir, question number. So answer option B, fx equals to 7 minus 3x.
Correct.
Then this is, I mean, sir, this will be the right option. But how?
So you are saying this should not be one of the correct option, is it?
Sir, option C should not be the correct option. I mean, sir, this is from my point of view.
No, option B is clear. Is option B clear to you?
Yeah, sir. Option B is clear. But option
Okay.
C, how?
Option
This...
C. Let's see. Minus 2x cube, right?
Yeah.
This is how the function look like, correct?
Yeah.
Okay. Now, if we increase x, is the value of function increasing or decreasing? That is the question, correct? If I increase x, so if I increase x,
it should be decreasing.
So it is a decreasing function.
Sir, I mean, how, sir? If we put x equals to some numbers, then how it could be decreasing?
Okay. What about x equal to -1? What is the value of that function?
Sir, 2.
X equal to -1, then it is 2, correct? And
Yeah,
at x equal to 1, what is the value of that function?
-2.
Is it so? We increased x, right?
Yeah.
But value is decreasing, correct?
Okay, okay, sir.
That is the point, no? That is the point of increasing and decreasing function.
Yeah, yeah, yeah,
So
yeah.
here only checking on positive and negative part will be enough because this function is passing through origin, correct? So on the both
Yes.
side of positive and negative, it will behave oppositely. So if
So
you just
we
take
have to.
if you just take two different positive and negative number and you can check, that will be enough for this function, this particular function.
Actually, sir, I was taking negative numbers and I
Then
was
also it
getting.
will be fine, no? What is for -2? So if you take negative number, then also there will be no issue. F of -2, what is the value of that?
So -8 and it should be plus
Right?
plus 16,
Plus
plus
6.
16.
What is f of -1? You just calculated.
Okay, okay, sir.
2, right? It is decreasing, but this is increasing. Correct. So,
Yeah, yeah.
I mean, you know how the x cube behave, function x cube.
Sir, it's a reflection of x cube, right?
Reflection of 2x cube, exactly. So that is why I was asking. So you know how x cube behave, right? X cube is an increasing function because whatever value we are giving, it is increasing, right? As a cubic
Yes.
power.
Yes, sir.
Now you are taking a minus to that. So it will be decreasing. And there is one positive coefficient with it too. It will be the same function. Okay?
Okay,
So
sir.
this is
Got
how
it.
you need to check. So
Yeah,
you
actually,
know the
sir, I
behavior
was
of
thought
x
that.
cube. Yeah, so you know the
Yes.
behavior of x cube. So you know
Yes.
the behavior of 2x cube. This is also increasing. Right? So
Yes,
if you take
yes.
minus, it will be the reflection of that. It will be decreasing. That is how we check.
Got it, sir.
Yeah, great. Okay. These I think most of these function I have discussed more or less, mod function and all this. This you can do now. These I have discussed in one of my earlier live session. Fx equal to mx plus c. M not 0 and c is an real number. Is this 1 to 1? So is this function 1 to 1? Fx equal to mx plus c.
Slope formula. I think that one not a function.
So you're saying it is not 1 to 1. Can you tell me why?
No, no, sir. Just no. I'm thinking. Slope. C is the y intercept. No, sir. It is 1-to-1 function only.
This is a straight line, right? This is a
Yes.
straight. It is 1 to 1 function.
Yeah.
Because m is not 0. If m is 0, then what happened?
M. Yeah, what's that?
If m is 0.
M is 0 means
It is 0.
it will be 0 only. Not value will come.
No, fx will be c.
There is no
No,
only
sir.
C.
Only
C.
C only because we cannot multiply with the 0, right?
So fx will be c, right?
Yeah.
And what is that function 1 to 1?
No,
Why?
that is y intercept,
So,
not x.
so
Sir, it will
I
tell
think this is
Horizontal line,
test.
1 to 1.
1-to-1. Horizontal line, sir.
this is just a horizontal line, right? This is constant function. Whatever value you put
Constant.
for x, the
Yeah,
function will be constant,
constant.
right?
Yeah.
Whatever value. So it will be same for all the input. So it is not 1 to 1.
Oh, not 1-to-1.
Yeah, any constant function is not 1 to 1 function. Okay.
Because x is not there, right, sir?
I mean, whatever input you give, the value will be fixed. The output will be fixed.
Yeah, same. Yeah,
It
yes.
is. So it is
Yes,
not
sir. Thank you, sir.
okay. Yeah, so these are more or less you can do these all problems.
Sir,
Sir,
can you
actually
take inverse
5.1.
function question?
Yeah, tell me which one. I have already discussed two inverse question. Yeah, tell me which question are you do you want to discuss? Do you have any
Sir, like
particular
not,
question or do you want me to
no,
take
sir.
any?
Yes, sir, anything like randomly you can select.
Whatever I have discussed, is that part clear? That inverse function? Were you there when I was discussing that?
Yes, sir.
Okay, fine. Let's see whether there is any inverse question here. This is composition function. This one is inverse function, right? Right. Okay, fine. Huh. So if I take these questions, question number two, can someone tell me what is the domain and range of the inverse function? So if can everybody see the question? Fx equal to root over x minus 5. Okay. Fx equal to, so let me write it. Fx equal to root x minus 5. The question is what is domain and range of f inverse x?
Uh, Domain is -5 to infinity.
Okay, so what is the inverse function first of all? What is domain of f? What is domain of f?
5 to
Is
infinity, sir.
-5 to
Ah,
infinity.
not minus 5. 5.
5 to infinity.
Five.
Sorry, 5 to infinity.
5 to
Exactly.
infinity. Yeah, we should include 5. This one, right? And what is range of f?
Positive real.
Right. R plus 0 to infinity. Okay. Now for this type of function, we have to give a function for which f compose g is identity, that is x, and g compose f is also identity. This is what we need, right? So for root x, we have seen it as x square for some restricted domain to 0 to infinity, right? When it was positive. So here it is something which is under root, right? But there is minus 5. So generally how g should look like? The inverse should look like root x square plus 5, right? This one. If I take this as g, what is g composite first of all? If f is x minus 5, sorry, this is not root x square plus 5, just. So what is this? This is root x minus 5 whole square plus 5. So this portion is clear. This is x. And this is for anything which is in the domain of f. Anything which is in the domain of f, that is 5 to infinity. Correct? Is this portion clear? What is domain of G compose f? Because this function, this G function, it is from R to R, R to R plus. Correct? So domain of G compose f is 5 to infinity. Is it clear? We are applying f first. So there is something which is 5 to infinity. I am applying f first. I am getting something here which is positive R plus, and on R plus I can apply because G is applied on, I mean domain of G is the set of real numbers, so obviously R plus is inside that, so I can apply G here. I will get something here, right? So domain is 5 to infinity. Is this portion clear to everyone?
Sir, how did we derive x square plus 5?
So I have done some problems, few problems earlier. No, what is basically inverse function of root x? It's x square, right? In R plus, correct? That is what we have calculated earlier,
Right,
correct?
right.
Okay. Now inside the square root, I have minus 5. So I have to cancel it out, correct? So for x square, I will get minus x, but I have this minus 5 to cancel out. So I am adding 5 in that function.
So that is fine, but why x square?
Because this is root x. So root x
Okay,
inverse is x square.
okay, okay.
So there should be a square component and I have to cancel out the constant now. Right? That is the idea. Clear? Is it clear? I mean, how I am guessing that this is the function.
Sir, I understood that much that if it is x square, then sorry, if it is root x, then we are putting x square, and to
Huh.
negate 5, we are adding a 5. So
Exactly. That is what
that is
it
it,
is.
right?
Yeah, correct.
Okay.
And then we have to check that whether our guess is correct or not, and that is what I am doing. Right? And we also have to find in which domain it is actually working. It may not be on R, right? It should be in some restricted domain, and that is what we have to find. Okay. So is this portion clear that it is from minus 5 to infinity for G compose F? And what about F compose G? Now this is interesting part. First we have to apply G, right? Now G is from whole R. This whole R is basically its domain, but range is only R plus. Range is R plus. This is your G function, correct? Now, if is F applied on whole R plus, what was the domain of F, if you remember? Domain of F was 5 to infinity. So it is a part of R plus, not whole R plus. So F is also a part of it. It is not whole. This only part of it. This portion is basically 5 to infinity. On this portion only I can apply F. And I am getting this. Is it clear? So what is domain of F compose G? It is R. Because input I can take anything. Because input I am giving inside G. Because the range I am getting for G, the domain of F is a part of that. And that is what needed to define the composition. Clear? Is it clear? But in this portion, so say 0 to 5, this portion is in range of G, but I cannot apply F on that. So I have to eliminate those elements from the domain of G for which I am getting 0 to 5 as output. Correct? So R minus something I should give. Can you tell me what is that? Is this clear what I am saying? Or should I explain it once more?
Minus infinity to 0, 5 to infinity.
Uh,
0 to 5.
so my point is G was defined on whole R, right? This was the domain of G. Now when I am applying G on whole R, I am getting R plus as my output. R plus is the range. But F is not applied on the whole R plus. F is applied on a portion of R plus. Only this portion. What is this portion? 5 to infinity. On this I can apply F to get some output. So I cannot include this portion. This
Yes.
portion.
Yes. 0
Right?
to 5.
This portion
Yes.
is basically 0 to 5. So for those input of G for which I am getting 0 to 5 as output, I should eliminate that. G was x square plus 5. So I should eliminate all those inputs which will give me 0 to 5 as my output. And what are those? What are those outputs? Actually, I have written something wrongly here. Can you point out where I am going wrong in this process? Can you tell me? So, where I have written wrong? This is where I have written wrong. What is range?
-5 to 0, sir.
Range of G is actually 5 to infinity. It does not include 0 to 5. So we don't have to bother about this. Okay? Because it is minimum thing is 0. So it is 5 to infinity. So 0 to 5 is not included in the range. So F is applied there on that portion. Yeah. So this is not included here. So domain of F compose G is remained as R. Okay?
Yes, sir. Yes.
Okay, fine. So what I am getting, domain of F compose G is basically R, and domain of G compose F is basically what we have calculated, 5 to infinity. Correct? These two we have calculated. Okay? And what was G compose F? G compose F was X. This is what we have calculated. What is F compose G? So G is x square plus 5. And now this is under root x square plus 5 minus 5. So root x square, this is mod x. Correct? Because domain of F composite, remember it was R. So in which domain, how can we restrict the domain? So that I can just write x here. I can ignore the mod part. Can you tell me what domain I should consider here? To ignore the mod part first. The negative I can exclude, right? If I restrict the domain as R plus, then F compose G is nothing but X, because only positive number I am talking about. Correct? Is
Yes.
it clear to everyone? Yeah.
Yes.
So, yeah. Now I can do that because for G composite the domain was 5 to infinity. So if for the both the function, when both the function will be equal, if we restrict the domain to 5 to infinity, because 5 to infinity is part of R plus, right? Because R plus is 0 to infinity and 5 to infinity is a part of it. It is a subset. Right? So if I take this as my domain, the intersection of these two, then what is G composite and F compose G? Then F compose G and G compose F, both of them are equal and they are nothing but X. So domain of F inverse is nothing but 5 to infinity. Is it clear? Is it clear to everyone?
Yes, okay.
Okay, great. Okay, so this is basically one type of, so this type of problem basically we have come across. Nothing else. Okay, so this is done. Okay, so here it is another type of problem. So question number 3, if you can see, for which of the following functions satisfy the condition fx equal to f inverse x? So basically, there are some functions for which the inverse is the same function for it, and you have to find which one that function is. Okay. So if I say, I mean, fx equal to x, can you tell me what the inverse function is? Fx equal to x. Fx equal to x, can you tell me what the inverse function should be? Anyone?
X.
Huh.
1.
So if I say gx is also x, if I apply f compose g, what I am getting? Gx is x, so fx, it is x. And what is g compose f? Again it will be like that. Fx is x, so g of x is again x. This is the same. And both of them are defined from R to R. So domain and range does not create any problem here. So for this function, fx equal to x, it is the same function actually we are talking about. Okay. So this is what we need. This there are some functions. For this function, inverse function is itself x. Okay. So there are few more functions like that, and you have to identify which one is it. Okay. So basically, how you can check this if these two functions are equal? If you compose this function with the function itself and see whether x is coming or not. If x is coming, then that function is the inverse of itself. Otherwise, it is not. Okay. Clear how to solve this problem?
Yes.
Oh,
Yes, sir.
okay. So I think this more or less cover whatever we have in week 5. And next week is quiz, so I don't want to spend more time here for week 5. Again, we will discuss later. Okay. So yeah, best of luck for your quiz, and
Sir,
we will
when will
meet
you
in
keep
revision.
revision for quiz?
Yeah, next week there will be revision session. Okay, next week there
Sir,
are
any
some revision.
particular day?
I have to check which day it was.
The quiz.
I think 11th we have a
16th.
revision session. Okay, 11th. 11th means Tuesday. 11th we have a revision session. And then 14th we have another revision session. Okay, 11 and 14. Okay.
Thank you, sir.
Those two sessions we will revise week 1 to 4 again. Okay. Okay, fine.
Thank you. Bye.
Thank you. Thank you so
Yeah.
much, sir.
Thank you, sir.
Thank you, sir.
Thanks.
Thank you, sir. Thank you.
Yeah.